Okay, we stopped at the point where we are on slide number 40, where I'm telling you just that you can determine or estimate the total clearance or systemic clearance from the data that you have from the infusion, or also the VD. And if you go back to the concentration equation that you have at certain time, you have R over K multiplied to VD, right? So if you have any idea about this, you are okay with this. This is already there and this is already known. We have this as systemic clearance, so you can determine the systemic clearance. And even if this is not known, okay, you can determine, we know that this is K VD equals the systemic clearance, so you can have the systemic clearance over VD here. So you can also, if the K is known but the systemic clearance is known, you can determine VD and vice versa. So from the bottom line, you can determine it from the equation that you already have. Okay, we were talking in the last video about having a loading dose, right? Using the IV bolus as our loading dose. Okay, so we will go to do the calculation of your example that you have on slide number 41, and let's see what the question is asking you. We have a physician that wants to administer drug at a rate of 2 milligram per hour by IV infusion. The elimination rate constant is equal to the volume distribution equals to 10 liter. And then he's asking you about the loading dose by bolus. Okay, so those are information about the infusion that you have. And then he's asking what will be the loading dose by bolus, IV bolus, recommended if the doctor wants to the drug level to reach if the desired concentration is equal to 2 microgram per milliliter, and we are giving this immediately, which means if we are talking about the sketch that we have, okay, then this CB versus time, we are taking this, which is the infusion, and I'm talking about immediate loading dose administration. And in the question, if you go back to the question, he's asking what the dose of the loading to give, what is the recommended dose. This is an important word, to give this concentration immediately. Okay, so what I want recommended, according to whatever just I explained in the last video, recommended will be to give you the target concentration directly, right? Which means that I need the targeted concentration, which is required to be 2 microgram per milliliter, to be reached directly. So if 2 microgram per milliliter is the steady state concentration of the infusion, then this means that I can use loading dose that is equal to R of the infusion or maintenance dose over K, right? But before I do this, I need to ask a question. Is 2 microgram per milliliter is or equal the steady state concentration of the maintenance? Okay, and to do so, you need to just determine the steady state of the maintenance or the infusion. Okay, and this will be our maintenance K VD K with time. We are talking about steady state, so this won't be there. So this will be, this is equal to 2 milligram per hour. This is 0.1 hour minus 1, and this is 10 liter. So you will have it equal to, when you go to the calculation, it will be 2 microgram per milliliter or milligram per liter. Okay, so again, it's the steady state, so I can go back and determine this by R of the infusion, which is equal to 2 milligram per liter, and this is 0.1 hour minus 1. So you will have it in the milligram per hour. So you will hours will go out with each other, and the final will be equal to 20 milligram. So the loading dose needed is 20 milligram. Okay, try to do this question using the total concentration equation, taking into consideration that he's asking what will be the dose needed immediately, which means what will be the dose at time equal 0. Try to do it and see what will be the loading dose, and you will see that it will be the same. Okay, another question which is 42. Again, the exercise or the example that you have slide 42, and then he's asking a question about if you have a time of 6 hours after administration of a loading dose by IV bolus loading equals 10 milligram and simultaneous, so we are taking them at the same time, of infusion that is equal to, which is our maintenance, this is infusion, equals to 2 milligram per hour. Okay, if you know that the half-life of the drug equals to 3 hours, then from this we can determine K 0.693 over 3 hours, which will be equal to 0.231 hour minus 1. And then the volume distribution equals to 10 liter. He's asking what? He's asking about the concentration at time equal 6 hours. So what we have is this. We are taking them at the same time. So we are this. We don't know if this is the total. It could be this. It could be this. It could be this. It could be this as total. We don't know, right? But he's asking what will be the concentration at 6 hours. So we don't know if the 6 hours is here or the 6 hours is here, right? So what we need to do, we need to have the total concentration at 6 hours total. We are taking them at the same time, so the time is the same, equal concentration of bolus plus concentration of infusion. Do we have any problem in this equation? No. Here we need to ask ourselves if we are at steady state or not, by knowing what? By knowing the time. The total time that we are asking about is what? 6 hours. The half-life is 3 hours, which means that we already have 2 half-lives, which means that we are not at steady state. So let's go to the substitution. This will be loading dose over VD, K with time, plus not a steady state, so it will be K VD. Okay, then let's go with the substitution. This will be 10 milligram, 10 liter, 0.231, 6 hours, liter, and it's liter, yes, and this is 2 milligram per hour, 0.231, and 6 hours. The time that you will have, the concentration that you will have total at 6 hours equal to 999 or 2 nines milligram per liter or microgram per milliliter. Okay, we will talk about the now about the other approach of loading dose, in which we will use the approach of combined slow with fast infusion. Okay, Okay, so let's go with another way to take the loading dose with infusion by fast infusion. Okay, let's go back of whatever I did just before. We have the infusion, and we have, this is what the desired. We have what? The loading dose of IV bolus. This is what we took just in the first option that we have. So this was the loading, and this was the maintenance by infusion, right? So another way of doing that is by taking the infusion, one infusion, but fast infusion. So when we are talking about fast infusion, it means that R is large. If R is large, it means what? Or the concentration at certain time is larger, because once it's higher, the concentration at steady state or concentration that we will have is higher. So the issue is that we will start with a fast infusion for a short period of time. It depends on your drug. If it's 6 hours, 60 minutes, half an hour, 45 minutes, 1 hour, it depends. Okay, so we will do the fast infusion for certain time until I reach the desired concentration that I want, which is the steady state that I have for my maintenance dose. Then we will terminate. Okay, so this will be the termination point of what? Or stopping the infusion of the loading infusion. So that's what we will do. We will give a fast loading, which is fast infusion, and we will have slow maintenance dose. This is infusion, and this is infusion. Why I keep it on the same graph? To show you that the only difference is that I give the infusion with the loading with infusion rather than bolus. But once you terminate, the drug will behave only with elimination. Okay? The question is now, if we are talking about this and we have termination at a certain point, what will be the total concentration? The total concentration was before it was this. For sure, if we are using the or reaching the terminal, the desired concentration, okay, this will be our total concentration. Okay, in another word, if we have bolus as loading, reach it for a short period of time. Again, I'm just expanding this part to show you, and then you will have this. Okay, you reach the steady state directly. This is under the condition, this is if we have IV bolus as loading, if we have fast infusion as loading. Okay, and this is total concentration, and this is total concentration. And again, this is under one condition, that I'm reaching the steady state concentration or the desired concentration that I need of the maintenance dose directly. Okay, that's why we have it as direct straight line, which is my steady state concentration. If not, I will have it with a little bit. If not, you may have this, or you may have this, as we said before. The same thing here. You may have this, or you may have this, right? It depends on the concentration that you are reaching, if it's right or not. But this is the desired that we need to reach the steady state that we have directly. From whatever you know already, according to whatever I just mentioned and the loading dose with IV bolus, if I want the concentration at any time point, it should be what? It should be the concentration total equals concentration of the first infusion, which is loading, right, at that time, plus the concentration of the slow infusion, again, at that time, which is the maintenance. So it will be the sum of both. And here you will have some kind of, you need to be accurate, and you need to concentrate of whatever that you are measuring. So if I know this, and I know how to determine the concentration with the infusion, you need to be able to determine the concentration of each one of them. Let's see how this works. Let's see the time. Okay, we need to finish, but let's just start with, we waited for a short period of time. We take this, and then this is the loading until I reach certain time concentration, and this is the second one, which is the loading. So we have this. We will talk about it in the second video, not now, and we will have this. Okay, so we will talk about this. If the concentration, again, total will be whatever that you have for loading plus whatever that you have for maintenance, right? And this is our loading, and this is our maintenance, right? So at any time point, and at any time point, you can have it from here. If you are asking here, there is no, this is 0, right? Before, in this time period, it's 0 already. If you are having it here, here, or here, as you know, you need to ask yourself, is it steady state or not steady state? As you know already, but for maintenance. So it will be either K, VD, or K, VD, 1 minus K with time. And here, you need to ask yourself another question. So the profile of us for the maintenance will be CB versus time, this until the termination, and then we will have this. So we need to know if we are at this range before we are giving the other one, in which we will have 0 of the maintenance, or after this point. I will just mention this point because you know it already. So this part, if we are at this part for the loading, okay? Can we determine the concentration at this part? In general, if it's not loading, you will ask yourself if this is if this concentration, it was just a profile of just an infusion with termination, you'll ask yourself if this is at steady state or not, right? In general, you'll do the same thing as here. But as we are using it for loading, we usually don't reach steady state. So we are usually not at steady state. Why? Let's go up and see why is that. Because if you wait until you reach the steady state, we know that increasing R, it means increasing the steady state. We are talking about loading, and this is by loading, which means the steady state of the loading, if you reach it, you will kill your patient. We don't do that. We just use it until we reach a certain concentration that we want, which is our desired concentration. Okay? So again, let's go back. If this was not a loading equation, not a loading dose, you will ask yourself if it's a steady state or not. But as it's not, and we will not reach a steady state, usually at this line, this concentration from this point to this point will be equal to R K VD 1 minus K with time. And for sure, this is time of the loading infusion, and this is loading, and for sure this is maintenance, and this is time of maintenance. Okay, I will stop it here, and then I will discuss this in details just in a minute. Okay.